Already we have seen the source transformation, that is voltage source to current source and the current source to voltage source, and what are the various cases. Some cases we observe. So now let us move to the next element. So two elements are over. Voltage source is over and current source is over. Next third element is resistor. Resistor. Yes, what do you mean by resistor? What is resistor? Which oppose the flow of current, or which oppose the flow of charge, which drops the voltage when current is passing through the resistor, which consumes an electrical power, and which dissipates an electrical energy into the form of heat. So this element is called resistor. Obviously, every element is having some amount of resistance. So in my point of view, every element is the resistor only. For example, being the human body, we have some resistance. Therefore, we are also resistors. We are also resistor. Yes, then how much resistance is there? How much resistance is there? We have two types of resistance. That is, during the dry condition, our body offers 1000 ohms resistance, and during the wet condition, our body offers 100 kilo ohms resistance. 100 kilo ohms resistance. So now let us see, the resistor is an element. Resistor is an element, and resistance is property of resistor. Property of resistor. Resistance is the property of resistor. So what is that property in a sense? The first one is oppose the flow of current or charge. Flow of current or charge. Next, drops voltage when current passing through resistor. Drops the voltage when current is passing through the resistor. And third one is consumes or absorb an electric power. Next, fourth one is dissipates an electrical energy into the form of heat. Yes, here I define the property of resistor, that is resistance, in four ways. That is, in the view of current, it opposes. In the view of voltage, it drops. In the view of power, it consumes or absorbs an electric power. And in the view of energy, it dissipates an electrical energy into the form of heat. This is the resistance. Now, how we find the resistance? That means the resistance of resistor, resistance of any material, that is physical significance. Physical significance. Every body contains the resistor. How we can find out this resistance? In a sense, the resistance of the body is directly proportional to the length, and it is inversely proportional to area of cross section. Therefore, R is proportional to L by A, and R is equal to rho L by A. where rho is called resistivity. Where rho is called resistivity or specific resistance. Specific resistance. So resistance of the material is directly proportional to the length and it is inversely proportional to area of cross section. Hence, if we combine these two, resistance is directly proportional to L by A. If you remove this proportionality is constant, then we have R is equal to rho into L by A. R is equal to rho L by A. Now here rho is called resistivity or specific resistance. And here in some examination they used to ask what are the units of resistivity or what are the units of specific resistance, and how we find this value. In the sense, we know that rho is equal to, from this equation, rho can be written as R into A by L. The units of R is ohms, the units of A is meter square, the units of L is meter. Hence, this can be written as ohm meter. The units of resistivity or the units of specific resistance is ohm meter. Okay. Now, what is the inverse of resistance? The inverse of resistance is called conductance. Just to see, inverse of resistance is called conductance, which is denoted by Z. G is equal to 1 by R. The reciprocal of resistance is called conductance. We know that R is 1 by rho L by A. This is called A by rho L. A by rho L. Here what is rho? Rho is specific resistance or resistivity, and 1 by rho is called conductivity. Yes, here 1 by rho is called conductivity. One by rho is called conductivity. So this can be represented by sigma. This can be represented by sigma. Hence, G is equal to sigma into A by L. Sigma into A by L. Now the units for conductance is mho. Conductance is mho. Then what is sigma? Sigma is equal to G L by A. G L by A. So units are mho, meters by meter square. Square, meter get cancelled. Then it is mho per meter. Therefore, the units of conductivity is mho per meter. Yes, for example, the value of rho is not constant for all materials. The rho value is changes from one kind of material or one kind of element to the other kind of element. But we have some maximum and minimum values of rho. That is, when the value of rho is equal to 0. Value of rho is equal to 0. When rho is equal to 0, then what is R? R is equal to 0. When R is equal to 0, such material or such element is called perfect conductor. Perfect conductor. And the next one, when rho is equal to infinity, rho is equal to infinity, then obviously resistance is also infinity. Then it is called perfect insulator. Perfect insulator. So based on the rho value, that is specific resistance, we can decide whether it is conductor or insulator like this. Now, we know, so if we want to define Ohm's law, how you define Ohm's law? At constant temperature. The condition is at constant temperature. Why it is defined at constant temperature? Because the resistance is varying with respect to the time. Resistance is varying with respect to the temperature, not time, sorry, it is varying with respect to the temperature. That means when temperature is increases, then resistance of the body is increased or decreased or may not be changed. There are three conditions are there. The first condition is the resistance of the body may be increased when temperature is increased. The resistance of the body may be decreased when temperature is increased. But the resistance of the body does not change, so even though the temperature is increased. So such material, so there are the classification of the materials based on the resistance, temperature, variations. We have three types of materials. Those are, the first classification is positive temperature coefficient material. Positive temperature coefficient material. And here what happened in the sense, when temperature increases, then resistance also increases. So here I want to define one temperature coefficient, which is called alpha. Here alpha is called temperature coefficient, and the units of alpha is per degree centigrade. The units of alpha is per degree centigrade, and here the value of alpha is positive. Therefore the name is imposed as positive temperature coefficient material. Can I give you an example? The example for such kind of materials is pure metals. Pure metals. So what is metal? Metal in the sense conductor only. Metal in the sense conductor. Generally we have the three types of conductors. What are those three types of conductors? The first one is silver is there. Next one is copper, and next one is aluminum. Silver, copper, aluminum. If you see these three types of material, the conductivity of silver is greater than conductivity of copper. The conductivity of copper is greater than conductivity of aluminum. That means conductance Z of silver is greater than conductance of copper, and it is greater than conductance of aluminum. Conductance of aluminum. And when I compare the resistance of these three materials, resistance of aluminum is greater than resistance of copper, and it is greater than resistance of silver. Resistance of silver. That means the silver consists minimum resistance, and aluminum consists minimum conductance. And moreover, when I compare with respect to the weight, so which material is weight? The aluminum is weightless, copper is somewhat weight, and silver is somewhat weight. Okay, like this. So this is regarding to the positive temperature coefficient material, in which when temperature increases, the resistance also increases. The temperature coefficient is positive. The best example is pure metals. And the second category is negative temperature coefficient. Negative temperature coefficient material. Negative temperature coefficient material. So here, when you increase the temperature, then resistance is decreased. Resistance is decreased. Then the value of temperature coefficient is negative. Value of temperature coefficient is negative. The best example for such kind is semiconductors, next insulators, next dielectric materials, like this. And you may have the doubt. So what is the difference between dielectric material and insulating material? If you see the properties of both, so both are same element. The properties are same for insulating material and dielectric material. But small change is there. What is that change? In the sense, the insulating material does not having the ability or capability to store the energy, but the dielectric material is having a capability or ability to store the energy. So that is the difference between insulating material and dielectric material. And one more category is zero temperature coefficient. Zero temperature coefficient materials. So when temperature increases, then resistance also increases. Just to see, when temperature increases, then resistance also increases, but the change in resistance is negligible. Change in resistance is negligible. Such material is called zero temperature coefficient material. The best example for such kind is alloys. The best example for such material is alloys. Alloys in the sense, the mixture of two or more elements. Two or more elements. For example, in electrical, you have the fuse. So the fuse is made up of which material? Yes, I think in your mind you have the copper. That is, copper may be used, but it is not copper. If you use the copper is positive temperature coefficient material. That means when temperature is increased, the resistance also increase. That means when the copper conductor carrying the current continuously, its temperature is increases. When such temperature is increases, then resistance also increase, which in which the current carrying capacity of the copper is decreased. In which the current carrying capacity of the copper is decreased. When current carrying capacity of copper is decreased, then at lower current itself, that fuse is melted. So hence it is not used. The copper is not used. Then which material we use? In the sense, we use the material which is called lead tin mixture. Lead tin mixture. Lead tin mixture. So lead tin mixture. So, and here also lead is 63% and tin is 37% like this. The mixture of these two in this fashion. So we used to design the fuse. That's next. This is positive temperature coefficient material, negative temperature coefficient material, and zero temperature coefficient material. Yes. The next one is, just for example, I have the resistance of the material at 0 degrees centigrade as R0. Yes, let us we consider. Let me take the resistance of the material at 0 degrees centigrade is R0. And the temperature coefficient is alpha naught. Temperature coefficient is alpha naught. Now my objective is to find out the resistance of the material at some temperature. That is, let me say that at T degree centigrade, so what is the value of R? In the sense, we have the formula, that is RT is equal to R naught into 1 plus alpha naught into T. This is very, very important. RT is equal to R naught into 1 plus alpha naught into T. Suppose, for example, one problem they have given. What is that? In a sense, the resistance of copper at 0 degree centigrade is 50 ohms. The resistance of copper at 0 degree centigrade is 50 ohms. And the temperature coefficient is 0.005 per degree centigrade. 0.005 per degree centigrade. Then what is the resistance of copper at 200 degree centigrade? What is the resistance of copper at 200 degree centigrade? Now you have the formula. What is the same formula you can use? That is R200 is equal to R0 50 into 1 plus alpha naught 0.005 into 200. Then if you solve this, you may have 15 to 1 plus 1. This is equal to 100 ohms. This is 100 ohms resistance. Okay, resistance of copper at 200 degree centigrade. Yes. The next one is, this is about the basics of the resistance. This is about the basics of the resistance. And the next one is, let us we move without delay to the Ohm's law. Ohm's law. Yes, what is Ohm's law? What is Ohm's law? At constant temperature, many persons used to say the Ohm's law is V is proportional to I, like that. The V never proportional to I. You should not say like this. So it is always the current is proportional to voltage, because the current is response. Voltage is excitation. How excitation is proportional to response? You should not say like that. The response is directly proportional to excitation. So then what is Ohm's law in the sense? At constant temperature, the current passing through the material is directly proportional to the applied voltage. That means I is proportional to V. Now we can write V is equal to IR, or I is equal to V by R. I is equal to V by R. Then how much power consumed by the resistor? That is P is equal to VI. That means we can substitute V is equal to IR. So IR into R. So this will be IR into I. This will be I square into R. Next, if you substitute in the same manner, P is equal to VI. And V, if you substitute the value of I, when value of I is equal to V by R. So it's V by R, then this is V square by R. V square by R. So hence the power absorbed or power consumed by the resistor is V square by R or I square R. V square by R or I square R. So now V square by R or I square R. So generally we use the power absorbed by the resistor is I square R. Then what about the energy? Energy is equal to power into time. Energy is equal to power into time. So energy is power into time. So that means you can write I square R into T. I square R into T. This is about voltage, current, power and energy of the resistor. As now I will give a small problem. This, what is that in the sense? For the network as shown in figure, the problem is for the given network, power delivered by voltage source is dash. For given network, power delivered by voltage source is dash. The problem is like this. Problem is like this. It is very simple cycle. That is, the value of voltage source is 10 volts, the value of current source is 2 amps, and here the resistance value is 5 ohms. The resistance value is 5 ohms. So here the options given as 20 watts, B 10 watts, C 5 watts, D 0 watts. The options are like this: 20 watts, 5 watts, 10 watts, 0 watts. So what may be the answer? So let me continue this answer in the next lecture, next part. So thank you for watching this video, and I am requesting you, so don't forget to subscribe the VVIT YouTube channel, and if you have any doubts, so kindly post in the comments column, or still if you want to contact me, so my email ID is iljbakthsingh@gmail.com. At the rate of gmail.com. So thank you once again.